There's something almost magical about unscrewing that jar lid for the first time. That satisfying crack of the seal breaking, the smooth surface untouched by human hands, perfectly level like glass. But have you ever stopped to wonder how something so simple, ground peanuts, becomes one of the most engineered food products in your pantry? Behind every jar of peanut butter lies a hidden world of precision machinery, scientific innovation, and industrial secrets that would surprise even the most devoted fans of this beloved spread. Most people think peanut butter is just crushed peanuts. They couldn't be more wrong. What you're actually consuming is the result of a manufacturing process so sophisticated that it took decades to perfect, involving temperatures calibrated to the exact degree, grinding mechanisms that operate at molecular precision, and quality control systems that would rival a pharmaceutical laboratory. The modern peanut butter factory isn't just a food processing plant. It's a temple of engineering where ancient legumes meet cutting-edge technology. Walk past any major facility at 3 in the morning, and you'll hear it. A deep, rhythmic hum that never stops. Somewhere inside those walls, right now, thousands of pounds of peanuts are being transformed every single hour. The air around these factories carries a distinct aroma, rich, toasted, almost hypnotic, that can be detected from blocks away. But what really happens behind those industrial doors remains one of food manufacturing's best-kept secrets. Here's something that will blow your mind. The average American consumes over 3 pounds of peanut butter every single year. That's roughly 700 million pounds nationally. To meet this staggering demand, a single modern peanut butter factory can process up to 250,000 pounds of peanuts in just one day. That's equivalent to the weight of 25 full-grown elephants being transformed into creamy spread before sunset. But the truly fascinating part isn't the volume, it's the precision. Peanut butter manufacturers have discovered that the difference between a product that flies off shelves and one that sits unsold comes down to measurements so exact they're calculated in microns. The particle size of ground peanuts must fall within a range of 20 to 30 microns for creamy varieties. That's smaller than a human hair, which measures about 70 microns in diameter. Get it wrong by even 5 microns, and suddenly your peanut butter feels gritty instead of smooth. The science behind preventing oil separation is equally mind-boggling. Natural peanut butter separates because peanut oil is less dense than solids. But commercial brands stay perfectly mixed for months, even years. How? Through a process called hydrogenation, where manufacturers add small amounts of fully hydrogenated vegetable oils that act as stabilizers. These oils have a higher melting point and create a crystalline network that suspends the peanut particles in place. It's essentially edible architecture happening at the molecular level. Temperature control during manufacturing is absolutely critical, and here's why. Peanuts contain natural oils that begin to degrade at 180 degrees Fahrenheit. But to achieve that perfect roasted flavor, factories need to hit between 320 and 340 degrees. The solution? Roasting happens in precisely timed intervals, usually between 12 and 15 minutes, using rotating drum roasters that ensure even heat distribution. The peanuts are constantly tumbling, never staying in one hot spot long enough to burn, but getting enough heat to develop those complex, nutty flavors we crave. What most people don't realize is that peanut butter manufacturing is one of the most automated food production processes in existence. Some facilities operate with as few as 12 human workers per shift, overseeing machines that do the work of hundreds. Robotic systems handle everything from sorting defective peanuts to stacking finished pallets. Advanced optical scanners examine every single peanut at speeds of 400 per second, rejecting any with discoloration, cracks, or irregular shapes. The rejected peanuts don't go to waste. They're typically redirected to animal feed or industrial oil production. The grinding process itself is where the real magic happens. Peanuts pass through not one, but two separate grinding stages. The first grinder uses steel plates with grooves that crush the roasted peanuts into a coarse paste. This paste then moves to a second grinder with much finer plates that reduce everything to that silky smooth consistency. Between these two grinding stages, the temperature of the peanut paste rises dramatically, sometimes reaching 170 degrees Fahrenheit just from friction alone. This heat actually helps release more oils from the peanut cells, contributing to the final texture. Quality control in these facilities borders on obsessive. Every single batch undergoes viscosity testing, where technicians measure exactly how the peanut butter flows. They're looking for a specific measurement called the Bostwick consistency, which determines how far the product spreads on a calibrated surface in 30 seconds. Too thick, and it won't spread easily on bread.
As you can see, our current incident rates anticipate significant decline compared to facing along.
Too thin, and it drips everywhere. The acceptable range is incredibly narrow, usually just a few millimeters of difference. The raw materials arrive at the factory in massive quantities that would astound most people. Peanuts are delivered in bulk trucks carrying up to 50,000 pounds at a time. These aren't just any peanuts. They're specifically selected varieties like Runner, Virginia, or Spanish peanuts, each chosen for particular characteristics. Runner peanuts, for instance, are preferred by most major manufacturers because they have a uniform size and high oil content, making them ideal for smooth, consistent peanut butter. Upon arrival, the peanuts still have their shells. The first major process is shelling, accomplished by massive machines that crack the shells using calibrated pressure, enough to break the shell but not damage the kernel inside. These shelling machines can process 8,000 pounds of peanuts per hour. The shells are collected separately and sold to other industries for mulch, cat litter, or even as fuel for biomass energy production. After shelling, the peanuts move through a series of cleaning stations where powerful air jets and vibrating screens remove any remaining shell fragments, dirt, or debris. Then comes blanching, a process where the thin, papery skin covering each peanut is removed. This happens in heated chambers where the skins literally crack off due to rapid temperature changes. The skinless peanuts then proceed to the roasting drums. Once roasted and cooled, the peanuts enter the grinding area. Here, additional ingredients are precisely measured and added. Salt arrives in 50-pound bags and is added at a rate of about 1% of total weight. Sugar, if used, comes in at around 2%. Stabilizers and emulsifiers are measured in even smaller quantities, sometimes just a few ounces per 1,000-pound batch. Everything is controlled by computerized systems that ensure consistency across millions of jars. The freshly ground peanut butter, now at the perfect temperature and consistency, flows through stainless steel pipes to the filling station. High-speed filling machines can fill, cap, and label up to 300 jars per minute. The jars themselves arrive on separate conveyor systems, pre-sterilized and inspected for defects. Each jar is filled with exactly the amount printed on the label, accurate to within 1 gram. Automated capping machines then seal each jar with precisely calibrated torque, tight enough to prevent leaks, but not so tight that consumers struggle to open them. Before leaving the factory, random jars from each batch undergo final testing. Technicians check for proper seal integrity, correct weight, appropriate consistency, and even conduct taste tests to ensure flavor consistency. Metal detectors scan every jar to ensure no foreign objects made it through the process. Only after passing all these checks do the jars get packed into cardboard cases, stacked onto pallets, and shipped to distribution centers. The entire journey from raw peanut to sealed jar takes less than 4 hours in a modern facility. That's the industrial miracle happening every single day, hidden behind factory walls, transforming one of nature's simplest foods into the perfectly engineered product sitting in your pantry right now. So next time you spread peanut butter on your morning toast, remember, you're not just enjoying ground peanuts. You're experiencing the result of decades of food science, millions of dollars in specialized machinery, and a manufacturing process so refined that it operates at the edge of what's technically possible. That's the hidden world inside every jar.
Let's review the output from this station.
Yes, the figures are consistent.
Good, we'll proceed with the next phase.
If you think peanut butter manufacturing is impressive, wait until you see what happens inside a high-tech chocolate chip cookie factory, where dough becomes perfectly baked cookies through processes that seem almost impossible. That video just appeared on your screen. Don't miss it. And if you enjoyed discovering the secrets behind peanut butter production, hit that subscribe button so you never miss another journey into the hidden world of how everyday products are really made. What surprised you most about peanut butter manufacturing? Drop your thoughts in the comments below.